All right, so today is the second part of Module 2, Lesson 1 in our geometry textbook. And we're going to focus today on special angle pairs. And so the first word we need to understand is the word adjacent. Adjacent means next to. All right, so you may have used this word at some point in your life, but in math, we got to be very careful with the definition. All right. And it's not going to be like it's a major vocab word, but when I talk about we're going to talk about things being adjacent or not all the rest of the year, or at least all the rest of semester 1. Right? And so if I have an angle, right, angle 1, and then I have another angle, angle 2, and they share this side. Right? Now they also share the vertex. Right? And so because they share the side, even though they're their own angles, they share a side, all right? They're adjacent angles. And so down here, this is a good example of adjacent angles. They have a common vertex. So angle 1 and angle 2 are adjacent angles. Over here, they don't quite touch. Like if you put them together, do they look like they could be adjacent? Absolutely. Right? And so that's why I'd be careful with the word next to. They share a common side. So that is not a set of adjacent angles. Right? So a special case, and then this is the first one. This is a major thing. We're going to use it all year. The other one, next one will be as well. A linear pair of angles. All right? And so a couple things you know about linear pair of angles, they form a line. The other way to say that is that they make opposite rays. The non-common sides make opposite rays. But a lot of times you just need to know that they form a line. And so right here is an example. All right, they're adjacent angles, but when they combine, even though there's two angles here, all right, when they combine, they make one straight line here. All right, and so that leads us to the even more critical linear pair theorem. And so super important here. The sum of the measures of the angles is 180 degrees. And so these two, I don't know what one is. I don't know what two is, but I know that together they would add up to 180 degrees. So how many degrees in a straight line? 180 degrees. Well, over here, I could add these together. I see that they equal 180, so therefore I know they're a linear pair. Vertical angles, right? Vertical angles are non-adjacent angles formed by intersecting lines. A lot of times I talk about vertical angles as being opposite, right? Or if we were in class, I would say, you know, it's like if you're facing away from each other, but you're butt to butt with each other, right? Meaning that like here in this example, angles 1, highlight, angles 1 and 3 are vertical angles. And angles 2 and 4 are vertical angles. They're kind of opposite of each other. They share the vertex, but they're kind of opposite or across from each other. So you really, this is again going to be one of those super important ones we're going to use a lot this semester, right? Vertical angles. We also need to know this vertical angles theorem. Vertical angles are congruent. Vertical angles are congruent. So if I'm looking at this example down here and I tell you angle 1 is 110 degrees, then you know angle 3 is 110 degrees. Because of linear pair theorem, 2 and 3 have to add up to 180, so this has to be then 70, because 70 plus 110 would make 180, and 2 is 70, 4 is 70. So if I know one of these angles, I end up knowing all 4 of those angles. All right. Let's show that over here. And so if I know right now that this angle 2 is 120, because of vertical angles, this is 120. Now, right next to each other here, 1 and 2 make a straight line. So they're a linear pair, so they equal 180. And so this one has to be 60 because it adds up to 180. Well, if 1 is 60, 3 is 60 because vertical angles are congruent. So it's a very important and commonly used, just because it speeds things up when you see it, commonly used. Let's go through these examples. There's multiple examples here of adjacent angles. Take a second, look at the picture. Do you see a pair of adjacent angles? Well, there's lots of right answers here. So the first angle I saw was angle ABE, which, is this angle ABE. Okay. And therefore it's adjacent rather, with it touches this angle right here, ABD. So they share AB. So ABE and ABD. That's just the first one I saw. I could have said angle ABE and angle EBC. So angle ABE and EBC share this little part BE. I could also say ABD and CBD, or EBC and CBD. All right. So there's multiple right answers here. I think we just named like 4 of them. All right. Hopefully you're able to understand at least one pair. Let's talk about the next one, which is vertical angles. So they're going to share a common endpoint or common vertex. So I got to work around B here. And they need to be across from each other. So there's 2 sets here. I could do this one here and this one here. They're across, or I could do this one here and this one here. Okay. And so either angle A, B, D and angle E, B, C. Now, with angle ABD, could I call that DBA? Absolutely. Okay. With angle EBC, could I call that angle CBE? Absolutely. Remember the 3 letters? The only letter that really matters, though, is that middle letter. And then angle, or I could use angle ABE, which is this top angle, ABE, and the one across from that's down here, so DBC. You only need one, because it's only asking name one, but I'm showing both examples. Linear pair makes a straight line. Okay. So there's 4 sets here. I can go this angle here and this angle here. Those two, that straight line right there on top, those 2 angles make that straight line. Or even I'm still talking about that straight line, these 2 angles down here on bottom make that straight line. Or if I talk about this straight line, the 2 angles on the left make that straight line. Or the 2 angles on the right make that straight line. So there's 4 possible examples. It's only asking us to name one. And so I'm going to say angle, just because every other time I've used the one that's on the left, let's use the one on the right here. So I'm going to say this one and this one. All right. And so angle EBC and angle DBC. Or I could have named it CBD. I could have named the first one CBE. Right. Again, it wouldn't be wrong if you stayed on the other side. Let's go to the top now. Angle AEBE and angle EBC. Right, that was this one and this one. That would have worked as well because they make the straight line right here. Find the measure of angle EBC. That's what that question's asking. That little m means measure. Find the measure of angle EBC. Well, first, where the heck is angle EBC? EBC is right here. And I can see right now that this angle and this angle are like across from each other. And so the word there, hopefully you remember, is it's vertical. All right, with this one. All right, so this is 138, this is 138. And so the answer here is it equals 138 degrees. Find the measure of angle ABE. Well, first, where is angle ABE? It's right there. Now, those two are next to each other. They're not across. They're next to, and they do make this line right here. So this angle ABD and this angle ABE make a straight line, which means they're a linear pair. All right. So that's the key word here, is that they're a linear pair. And I have to know that means they equal 180. And so I'll call this X for right now. X plus 138 equals 180. And so I minus 138 from both sides. I get X equals 42 degrees. And so that means ABE equals 42 degrees. All right, give this one a try. Pause the video here. Take a second to read it. It says, Mara wants to make a small table for her room. She found a design online that she likes, but she needs to know the measure of angle BAE. All right, find the measure and provide a justification. So find the measure of angle BAE and explain why you know that. All right, you can continue to pause if you need to, but we're going to talk about it here. This angle that they gave you right here and BAE form this straight line. And so they add up to 180. So this is 108. All right, because that makes 180. And that's because of linear pair. All right, and so they use the word supplementary. I don't know if we've talked about that a lot in class yet, but we have talked about linear pair today. So hopefully you got that. All right, go ahead and give it a try.